Good day, everyone. Today we'll be covering the family Vibrionaceae, a clinically important group of waterborne bacteria. These organisms are comma-shaped or curved bacilli, and the first thing we always remember is their single polar flagellum. That means they're monotrichous, so they swim really fast. They are oxidase positive organisms and they can reduce nitrate to nitrite except for one outlier, Vibrio michnikoviae. Most Vibrio species are halophilic, meaning they love salt, but remember two exceptions, Vibrio cholerae and Vibrio mimicus. Among the Vibrio species, only two stand out in human disease. Most frequently, it's your Vibrio cholerae and Vibrio parahemolyticus. So, Vibrio cholerae, it is found primarily in the human intestinal tract as its natural reservoir. So while Vibrio parahemolyticus, it is a salt-requiring free-living organism commonly found in seawater. So these two species are the ones you will most likely encounter in the laboratory and as well as in the future board exam questions. So in order to differentiate Vibrio from other curved bacilli, we use the strain test. We mix the organism with 0.5% of your sodium deoxycholate, which is a bile salt. If a viscous mucoid string forms when pulled with an inoculating loop, that's a positive result, which is a characteristic of Vibrio species. So this reaction happens when because the bile salt lyses the bacterial cell wall, releasing DNA. So this DNA gives the stringy effect. Now let's talk about Vibrio cholerae. Vibrio cholerae is the causative agent of Asiatic or epidemic cholera. These are two biovars you must know. So we have the classical Vibrio cholerae or the Eltor Vibrio cholerae. So classical Vibrio cholerae is also known as Vibrio in the old pandemics, while your Eltor Vibrio cholerae is also known as the Vibrio in modern pandemics. Okay, so when we talk about classical Vibrio cholerae, they are non-hemolytic, they are Vogt-Proskauer negative, they are also polymyxin B sensitive. But we talk about L-Tor Vibrio cholerae, they are hemolytic, they are VP positive, they are polymyxin B resistant. So you need to remember that you really need to compare these two. So there are three major serogroups based on the O antigens that they have. So we have Ogawa, we have the A and B antigens, which is common in India. Inaba, AC antigens, which is common in the Philippines. And then Hikojima, which has the ABC antigens, which is common in Japan. So these differ only by the presence or absence of your A, B, and C antigens. So please don't forget of where they are commonly found or isolated. Now let's proceed to the virulence factor of your Vibrio cholerae. So the major virulence factor of Vibrio cholerae is choleragen. It is also known as your cholera toxin. So this toxin stimulates hypersecretion of water and electrolytes, leading to profuse watery diarrhea. So here's an important point. Vibrio cholerae does not invade tissues. It stays in the gut mucosa and releases toxin. So we also have the effect of action of choleragen. So due to the toxin's action, we get the classic rice water stool or rice watery stool, which contains fluid, mucus flecks, epithelial cells, of course your Vibrio. Then this stool appearance is a hallmark question in future board exam question in your future board examinations. Next, let's have the clinical manifestations of cholera. So in order to cause a disease, a person must ingest a large number of organisms, usually 10 raised to the power of 8 up to 10 raised to the power of 10. The incubation period is short. It usually spans from hours to days. So once the disease starts, it is dramatic. There is a sudden onset of diarrhea and as well as vomiting. So up to 1 liter of stool per hour, and then you are going to lose fluid, usually 15 to 20 liters per day. And then this leads to hypovolemia, acidosis, shock, and eventually death. There are also physical signs which include sunken eyes and cheeks, poor skin turgor, and as well as the so-called washerwoman's hands due to dehydration. For the treatment, the cornerstone of cholera treatment is fluid and electrolyte replacement. So you have IV fluids. You can also have ORS or oral rehydration solution. And then antibiotics such as tetracycline shortens the duration, but it is supportive, but it is not really the main therapy. For the prevention and control, preventing cholera involves ensuring clean water, but this is expensive. So there are more practical methods such as repairing water systems, boiling the water before using or drinking, then chlorination, commercial water, ORS availability, community education, in which all focus on interrupting the fecal oral route cycle. For the diagnostic laboratory tests, we collect mucus flecks from the stool. So microscopy is not very helpful. Excuse me. Nothing distinctive. Culture media include peptone agar, blood agar at pH 9, which is alkaline, your TCBS or your thiosulfate citrate bile salt sucrose agar, in which Vibrio cholerae will have yellow colonies. We also have the taurocolate peptone broth for enrichment, in which usually you will have 6 to 8 hours in peptone broth enrichment. So remember that Vibrio loves alkaline environment, so alkaline media enhances recovery. Next, we have your Vibrio parahemolyticus. So this is the second most common Vibrio species causing gastroenteritis. So it was first recognized in Japan in 1950, and it is the number one cause of summer diarrhea. What is the common source? We have seafood, especially raw or improperly stored items. For the clinical infection is usually self-limited. Symptoms would include watery diarrhea, cramps, vomiting, minimal fever. Usually it begins 24 to 48 hours after eating contaminated seafood. So for the treatment, it is mainly fluid therapy since disease is usually mild. Control measures include proper refrigeration, cooking seafood thoroughly, and then one important laboratory feature is the so-called Kanagawa phenomenon. So Kanagawa phenomenon, it is an event wherein there is a production of hemolysin and virulence potential, so which is what I have said, known as your Kanagawa phenomenon. So most clinical strains of your Vibrio parahemolyticus will produce a heat-stable hemolysin. So in which this hemolysin can lyse human RBCs in your Wagatsma agar, which is a high salt medium. And if hemolysis occurs, then this type of organism which is present on your agar is Kanagawa positive. Next, we have your Vibrio vulnificus. So after cholera, Vibrio vulnificus is considered as the second most serious Vibrio infection after cholera. It is dangerous because of rapid progression to sepsis. So infections come in two major forms. So we have primary septicemia, and the second one is the wound infection. For primary septicemia, from ingestion of raw oysters, there is a rapid onset, and then the mortality rate would range from 40 to 60%. For the wound infection, it occurs after a traumatic aquatic injury. So it presents as cellulitis, and then it can occur even in people without immuno compromise conditions. Next, we have Vibrio alginoliticus. So this species is the least pathogenic of the major Vibrio species. So it is a strict halophile requiring at least 3% of your sodium chloride and can tolerate up to 10%. This is commonly found in marine environments, especially water. So to summarize, Vibrio species are curved, oxidase positive, and mostly halophilic. Vibrio cholerae causes life-threatening dehydration due to cholera toxin. And then Vibrio parahemolyticus is a seafood-associated summer diarrhea pathogen. Vibrio vulnificus causes severe septicemia and wound infections, while Vibrio alginoliticus is the least pathogen but extremely salt-loving. So you'll encounter these organisms repeatedly in clinical practice and in board exams. So mastering their unique traits is crucial. So let me give you some tips on how you're going to memorize them. So when we talk about cholera, so it's related to your toxin, and then the characteristic rice water stool, and then we also have the L-Tor type. And then we also have parahemolyticus, which is commonly found in seafoods. It is also associated with the Kanagawa phenomenon. For Vibrio vulnificus, usually it can be isolated in oysters, and this has a rapid onset which can progress immediately into deadly sepsis. And then we also have alginoliticus, which is a salt-loving organism. So as we conclude our lesson on Vibrionaceae, remember this. So even a single drop of contaminated water can change a life. And also, can a single accurate laboratory finding. So your knowledge, your skill, and your vigilance as future medical laboratory scientists make the difference. So thank you and stay committed to excellence. See you soon, everyone. Thank you for listening.